When dealing with projects constructed on former municipal landfills, addressing methane concerns is paramount, especially regarding electrical installations. While the National Electrical Code, referred to as NEC, doesn't specifically address methane in landfills, it provides general requirements for electrical installations in hazardous classified locations. Firstly, review all building codes and regulations. Local building codes or regulations may have specific provisions for methane mitigation in former landfill sites, so consulting with local authorities is crucial for guidance. Secondly, understand the area classification. Based on the presence of methane, the area under the building slab is likely classified as a Class 1, Division 1 hazardous location. This classification indicates a high risk of flammable gas accumulation and necessitates special electrical precautions. Thirdly, address under-slab installations. All electrical conduits, boxes, and other equipment installed under the building slab must comply with Article 501 of the NEC. This typically requires the use of explosion-proof or flame-proof equipment, rigid metal conduits, and special seals to prevent the entry of methane into the electrical system. Fourthly, consider site lighting and other fixtures. Site lighting fixtures, ground-based illuminated signs, and other electrical equipment not located under the building slab may not require the same level of protection as those installed underground. However, they should still be evaluated for potential exposure to methane. If there is a risk of methane accumulation, explosion-proof or flame-proof fixtures should be used, and conduit should be sealed to prevent gas entry. Fifthly, prioritize grounding and bonding. Proper grounding and bonding is essential to prevent static electricity buildup and potential ignition sources. Ensure that all electrical equipment and metallic structures are properly grounded and bonded according to the NEC. Sixthly, implement ventilation and monitoring. Install a ventilation system to prevent the accumulation of methane within the building. Also, install methane detectors to monitor for gas levels and activate warning systems if hazardous levels are detected. Seventhly, collaborate with experts. Consider consulting with an environmental engineer, geotechnical engineer, or other experts to assess the specific methane risks and develop appropriate mitigation measures. Eighthly, involve the local authority having jurisdiction, known as AHJ. Involve the local AHJ in the process to ensure compliance with local codes and regulations. They may have specific requirements or guidance for landfill projects. Additional considerations include aesthetic concerns which can be addressed by using concealed conduits, recessed boxes, or alternative design solutions that minimize the visibility of explosion-proof equipment. It's important to note that requirements may vary depending on the specific project and local regulations. Consulting with qualified professionals and local authorities is recommended to ensure compliance and safety. Now let's delve deeper into specific aspects of dealing with methane in these environments. The classification of Class 1, Division 1 signifies that ignitable concentrations of flammable gases or vapors are present continuously, intermittently, or periodically under normal operating conditions. This demands stringent measures in electrical design and installation. Explosion-proof equipment, as mandated by Article 501 of the NEC, is designed to contain an internal explosion without causing ignition of the surrounding atmosphere. This involves robust enclosures and specific construction techniques. Flame-proof equipment offers a similar level of protection. When selecting conduits, rigid metal conduit, either steel or aluminum, is generally preferred for its durability and ability to withstand physical damage and provide a continuous ground path. Seals are crucial in preventing methane from migrating through the conduit system. These seals are typically installed at specific points, such as where the conduit enters an enclosure or passes from a classified to an unclassified location. The NEC specifies the requirements for sealing fittings and compounds. For site lighting and signage, assess the risk of methane exposure carefully. Even if these fixtures are not directly underground, methane can migrate through the soil and accumulate in enclosed spaces. If there's a potential for methane to be present, explosion-proof or flame-proof lighting fixtures should be used. Furthermore, consider using sealed LED lighting fixtures, which reduce the risk of ignition due to their lower operating temperatures. Grounding and bonding are critical for preventing static electricity buildup, which can be an ignition source in a methane-rich environment. All metallic components of the electrical system, including conduits, enclosures, and equipment, must be properly grounded and bonded to create a low-impedance path for fault currents. This helps to minimize the risk of electrical shock and ignition. Ventilation systems play a vital role in mitigating methane accumulation. These systems can be designed to actively extract methane from the soil or to provide adequate air circulation to prevent methane from reaching hazardous concentrations. Methane detectors are essential for continuous monitoring of methane levels. These detectors can be connected to alarm systems that provide warning in case of a methane leak or accumulation. The alarm system should be designed to automatically shut down electrical equipment in the event of a hazardous condition. Working with environmental engineers and geotechnical engineers is crucial for understanding the specific methane risks associated with a particular site. These experts can conduct site assessments, monitor methane levels, and develop mitigation strategies. Involving the local AHA early in the project is essential for ensuring compliance with local codes and regulations. The AHA can provide guidance on specific requirements for electrical installations in hazardous locations and can help to ensure that the project meets all applicable safety standards. While explosion-proof equipment is designed to be functional, it may not always be aesthetically pleasing. However, there are ways to minimize the visual impact of this equipment. Concealed conduits can be used to hide the wiring. Recess boxes can be used to mount electrical devices flush with the wall or floor. Alternative design solutions, such as using decorative enclosures or integrating the electrical equipment into the building's architecture, can also be explored. Remember that the specific requirements for electrical installations in methane-prone areas can vary depending on the project and local regulations. It's always recommended to consult with qualified professionals and local authorities to ensure compliance and safety. Article 501. At the NEC is your go-to resource for detailed requirements on electrical equipment and wiring methods in Class 1, Division 1 and Division 2 locations. This article covers everything from explosion-proof enclosures to sealing requirements to wiring methods. When selecting equipment for these locations, ensure it's specifically listed and labeled for use in Class 1, Division 1 environments. Look for markings that indicate the equipment has been tested and certified by a recognized testing laboratory. Proper installation is just as important as selecting the right equipment. Follow the manufacturer's instructions carefully and ensure that all connections are made properly. All threaded joints must be properly tightened to maintain the integrity of the explosion-proof enclosure. Sealing fittings are a critical component of an electrical system in a Class 1, Division 1 location. These fittings prevent the passage of gases, vapors, or flames from one portion of the electrical system to another. Sealing fittings must be installed within 18 inches of enclosures that house devices that could produce arcs, sparks, or high temperatures. They must also be installed where a conduit leaves a Class 1, Division 1 location. The type of sealant used in these fittings must be specifically listed for use with the type of gas or vapor present. Regular inspections and maintenance are essential for ensuring the continued safety of an electrical system in a Class 1, Division 1 location. Conduct visual inspections to check for any signs of damage or deterioration. Test the operation of all safety devices, such as methane detectors and alarm systems. Keep detailed records of all inspections and maintenance activities. Continuing education and training are crucial for anyone working with electrical systems in hazardous locations. Stay up to date on the latest codes, standards, and best practices. Attend training courses and workshops to enhance your knowledge and skills. Remember, safety is always the top priority when working with electrical systems in methane-prone areas. By following the guidelines and recommendations outlined in this guide, you can help to ensure a safe and compliant installation. Consider the specific type of methane present, as different types of methane may require different mitigation strategies. Conduct a thorough site assessment to determine the extent of methane contamination. Develop a comprehensive methane mitigation plan that addresses all potential risks. Implement the methane mitigation plan in a timely and effective manner. Continuously monitor methane levels to ensure that the mitigation plan is working as intended. Be prepared to adjust the methane mitigation plan as needed based on the results of monitoring. Communicate effectively with all stakeholders, including building owners, tenants, and employees, about the risks of methane and the steps being taken to mitigate those risks. Provide training to all employees who may be exposed to methane. Post warning signs in areas where methane may be present. Keep records of all methane monitoring and mitigation activities. Work closely with the local AHA to ensure that all applicable codes and regulations are being followed. Seek guidance from qualified professionals such as environmental engineers and electrical engineers as needed. By taking these steps, you can help to ensure the safety of people and property in areas where methane may be present. The NEC provides specific guidelines on wiring methods acceptable for Class 1, Division 1 locations. Common wiring methods include rigid metal conduit, intermediate metal conduit, and cable types specifically listed for hazardous locations, such as MCHL cable. When using conduit, all joints and fittings must be threaded and properly tightened to maintain the integrity of the explosion-proof system. Cable types listed for hazardous locations typically have a special outer jacket that is resistant to chemical attack and physical damage. The selection of the appropriate wiring method depends on several factors, including the type of hazard present, the severity of the hazard, and the physical environment. The NEC requires that all electrical equipment in Class 1, Division 1 locations be approved for the specific hazardous atmosphere present. This means that the equipment must be tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or FM approvals. The equipment must also be marked with the appropriate class, division, and group designation. The group designation indicates the specific type of flammable gas or vapor that the equipment is approved for. For example, equipment approved for Group A is suitable for use in atmospheres containing acetylene, while equipment approved for Group B is suitable for use in atmospheres containing hydrogen. The proper selection of electrical equipment is critical for preventing explosions and fires in hazardous locations. The NEC provides detailed requirements for grounding and bonding in Class 1, Division 1 locations. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault currents. Bonding is the process of connecting different pieces of metal equipment together to create a low impedance path for fault currents. Proper grounding and bonding are essential for preventing electrical shock hazards and for minimizing the risk of ignition in hazardous locations. The NEC requires that all electrical equipment in Class 1, Division 1 locations be grounded and bonded in accordance with Article 250. This article provides detailed requirements for grounding electrode systems, grounding conductors, and bonding jumpers. The NEC also requires that all metallic conduits and enclosures be bonded together to create a continuous ground path. This can be accomplished by using bonding bushings or bonding lock nuts. Remember that the goal is to minimize the risk of electrical shock and ignition in these hazardous locations. The NEC requires that all electrical systems in Class 1, Division 1 locations be designed and installed in accordance with the principles of intrinsic safety. Intrinsic safety is a technique for designing electrical equipment and systems that are incapable of releasing enough energy to cause ignition even under fault conditions. Intrinsically safe circuits are typically low voltage, low current circuits that are designed to limit the amount of energy that can be stored or released. The NEC provides detailed requirements for intrinsically safe systems in Article 504. This article covers topics such as intrinsically safe apparatus, intrinsically safe circuits, and intrinsically safe wiring methods. Intrinsic safety is a complex topic, and it is important to consult with a qualified electrical engineer when designing and installing intrinsically safe systems. The NEC requires that all electrical equipment and systems in Class 1, Division 1 locations be inspected and maintained on a regular basis. Regular inspections and maintenance are essential for ensuring that the equipment is in good working order and that it is safe to operate. The NEC does not specify a specific frequency for inspections and maintenance, but it recommends that the frequency be determined based on the severity of the hazard and the operating conditions. A qualified electrical inspector should perform inspections and maintenance. The inspector should be familiar with the NEC requirements for Class 1, Division 1 locations and should have the necessary tools and equipment to perform the inspections and maintenance properly.